Hi students, my name is Miss Gardner and I teach chemistry at Riverside High School. So let's do a little bit more practice drawing Lewis structures of all different types, single, double, and triple bonds. All right, so we talked a little bit in class today about this rule, not really rule, but kind of a fun name that we can remember that's called HONC 1, 2, 3, 4, HONC 1, 2, 3, 4. All right, and this rule tells us that we see these atoms, hydrogen, oxygen, nitrogen, and carbon, a whole lot in covalent molecules. They are a foundational part of all organic molecules, these four right here. So hydrogen likes to form one bond. Hydrogen just has one valence electron, which will pair with another valence electron to make a single bond. So hydrogen will only ever have one bond. Oxygen likes to have two bonds around it. Nitrogen likes to have three bonds around it, and carbon likes to have four bonds around it. Now, this is not always true, but this happens commonly enough that we can start to see some patterns and make some predictions about molecules. Okay, so let's look at this in action. Let's see what I'm talking about here. All right, so I'm going to compare two molecules. I'm going to compare carbon dioxide and water, and we'll see how does this apply to our HONC 1, 2, 3, 4 rule. All right, so carbon dioxide, we've drawn this one before. This is one that eventually you should have memorized. All right, so rather than taking the time to do all the steps, we should have done it a couple times now. So we know that we have a carbon in the center. Carbon is flanked by two double bonds to our oxygens, and then each of those oxygens has four non-bonded electrons. All right, so this is CO2, the Lewis structure. Okay, so let's compare that to H2O, another molecule that you should have memorized eventually because we've drawn this so much, and you'll see it all the time, definitely in biology as well. All right, so H2O has an oxygen in the center, single bonded to some hydrogens, and then the oxygen has four non-bonding electrons around it. All right, so if we look at each of these molecules, we can see that each of these follows what HONC 1, 2, 3, 4 has predicted. Okay, so let's look at this carbon in the CO2 over here. All right, so this carbon, it has two sets of double bonds. So altogether, that means it has four bonds. All right, so this carbon has four bonds around it. All right, each oxygen here has a set of double bonds and then four non-bonding electrons. All right, so this oxygen has two bonds right here, and this oxygen also has two bonds. All right, and then notice it has those four non-bonding electrons around it to give it the octet. Okay, so let's look at this H2O molecule over here. All right, each hydrogen has one bond, a single bond. It doesn't have any non-bonding electrons because remember, hydrogen only prefers to have two electrons around it. That would fill its first energy level. And so hydrogen's an exception. It has a duet of electrons rather than an octet. All right, so this hydrogen also has one bond. And then this oxygen here, it has two single bonds, but still two bonds overall and four non-bonding electrons. Okay, so oxygen can have a double bond or two single bonds, but either way, it's still following that HONC 1, 2, 3, 4 rule. All right, our carbon here is following this as well. It has four bonds around it. And hydrogen, of course, has our one bond. Okay, so let's look at another example. Let's look at another example of a carbon-containing compound. All right, so another molecule that you are going to see over and over again is methane, or CH4. All right, so CH4 has a carbon in the center with four single bonds to hydrogen. All right, so again, each hydrogen in our methane molecule has a single bond. So it's still following our H and 1. The carbon in this central one has 4 single bonds to it. All right, so it's still following this rule where it prefers to have 4 bonds, but in this case, it's 4 single bonds, whereas in CO2, it was 2 double bonds. And guess what? We can have another version, another combination of single and double bonds for carbon. So another molecule I'm going to draw is H2CO. Okay, go ahead and do this one on your paper as well with me, because this one is, I don't think we've done this one as practice before, and it will be a good practice molecule. All right, H2CO. All right, this is actually the molecule formaldehyde, so you might have heard of that before. All right, so we'll start off by figuring out how many total valence electrons do we have. All right, so I have 2 hydrogen. They each are giving me 1 valence electron. So 2 times 1 gives me 2. All right, I've got 1 carbon that has 4. And I have 1 oxygen that is giving me 6. All right, so I will add those all together, 6, 10, and 12. Okay, so I have 12 total valence electrons to place for this molecule. Okay, make sure you have this written down. I'm going to erase it so I can draw my molecule. Okay, so 12 valence electrons to place. We have 3 different types of atoms here, but let's still follow our rules. We're going to put the one in the center that has the least number. So that could be carbon, that could be oxygen. But remember, if it's carbon, carbon should be in the center. Okay, so I'm going to put carbon in the center here. And I am going to put my 2 hydrogens around it. I'll just put those in kind of the west-south direction. And I'll put my oxygen up here, kind of north above carbon. All right, let's connect them all with single bonds. And remember, we have 12 valence electrons to place around this molecule. All right, so here's 1, 2, 3, 4, 5, 6. Okay, we've used up 6 of these valence electrons. We're down to 6 to keep adding until everything has their octet. All right, are we going to add any of those electrons to hydrogens? Hopefully you answered no, because hydrogen is only ever going to have a single bond. It's not going to have any non-bonded electrons to it. And it has its duet. It's that small exception. Okay, so let's place these on, I'll start here on oxygen. Nope, that's not what I want. All right, 1, 2, 3, 4, 5, 6. Okay, perhaps you put a pair of those on carbon. Okay, so now I've placed all of my valence electrons. Everything's done. My last step is to check, does everything have an octet? All right, I'm gonna just kind of check things off. Well, hydrogen has a duet, those look good. This oxygen here, it has 6 non-bonded and then 2 in the bond, so that has an octet. Okay, that looks good. And then we have carbon, it has 3 bonds around it, so that means it has 6 electrons. Okay, so this is not a complete molecule. Carbon does not have an octet. So we have learned that this is where we create a double or a triple bond. All right, so there's no electrons to pull from the hydrogens, but let's take a pair from oxygen and convert that into a double bond. All right, so then I'll redraw my molecule over here. So I've got carbon, double bonded oxygen with this. I've got a hydrogen here and a hydrogen here. Okay, so this is my final molecule, this one down here. All right, so how many bonds does carbon have around it? Well, it has 2 single bonds, right? So it's got 1 bond here, 2 bonds, and then it has a double bond, right? So this would be 3 and 4. So even though this carbon has a different configuration than my methane or my CO2, this carbon has 4 bonds around it. Okay, what about our oxygen? Well, our oxygen has 2 bonds in the double bond, and then it has 2 dots on either side, so 4 non-bonding electrons. And then each hydrogen here has 1. Okay, so all of these molecules still follow our HONC 1, 2, 3, 4 rule, even though we can have a carbon with 2 double bonds, a carbon with 4 single bonds, or like our molecule down here, a carbon with a double and 2 single bonds. Okay, let's go ahead and clear that. And so the only one that I haven't really talked about is nitrogen. So let's draw a couple molecules with nitrogen and see how it follows this rule. So nitrogen prefers to have 3 bonds. And if you think about the dot structure of nitrogen, it has 5 valence electrons. All right. So these 3 non-bonded electrons here, I mean, not non-bonded, excuse me, non-paired electrons, those ones, you can think of those as like nitrogen's putting its hands out, trying to hold someone's hand. Maybe they have 3 arms and wants to form a bond with something. So nitrogen is just ready to form 3 bonds. All right, so a common molecule that you'll see again and again is ammonia, and that is NH3. All right, so let's go ahead and draw that Lewis structure. Again, this is another one that you'll hopefully have memorized. So nitrogen has 5 valence electrons. We have 3 hydrogens. They each contribute 1, so 3 times 1 gives me 3. So 5 plus 3, so I have 8 valence electrons total. Okay, so I'm going to put nitrogen in the center. I'm going to put my hydrogens west, south, and east. All right, single bond to everything towards the center. So that's using 1, 2, 3, 4, 5, 6. All right, so now we have 2 more valence electrons. We're not going to add them to hydrogen. They all are all set, so we will just add our remaining 2 valence electrons to nitrogen. Does nitrogen have an octet now? Yes, it does. It has 6 electrons around it in single bonds and 2 non-bonding electrons. Okay, so what about N2? N2, or nitrogen gas. All right, this one, I know we have drawn this before, so I'm going to do this one quickly. But this one will be nitrogen triple bonded to itself, with each nitrogen having a pair of non-bonded electrons. All right, so notice this one here. This nitrogen has 1, 2, 3 single bonds, and then this nitrogen has a triple bond. But all of them follow this rule where we have 3 nitrogens. 3 bonds to nitrogen. All right, and likewise to carbon, we could have a nitrogen that has a double bond to something and a single bond, and then it would have 2 unpaired electrons around it. Okay, so hopefully you've started to see that there are some patterns, and you'll be seeing a lot of similar shapes and structures over and over again. And just keep on doing the practice. Really, these come so much easier once you have practiced them. So keep on doing your practice, and we will see you in class.